Good day everyone. This video will talk about Module 13, which is about Z-test. I, Rania Haji Zakaria Pama, will report this module together with Arafat P. Umpia, Kasmira Im Usman, and Johaira Ronda. Please listen and watch carefully.
Z-test, the simplest and common test on the significance of sample data, where it can be used to test alternative hypotheses against a null hypothesis, and sample size n is 30 or up. Also, this test is one of the parametric tests since it utilizes population parameter U and O. In other words, ang G-test is isa sa mga test na ginagamit natin kung ang objective ng study mo ay makahanap ng significant difference between sample mean and hypothesized mean. Sa Z-test din, ang parametric ay applicable given ka ng mean, either sample man yan or population ng mean. There are two types of hypothesis, a null hypothesis and alternative hypothesis. Null hypothesis, a hypothesis that a researcher tries to disapprove, reject, or nullify. While alternative hypothesis, a hypothesis that the researcher really thinks is the cause of phenomenon. Differences a null hypothesis and alternative hypothesis. In null hypothesis, there is no association with two groups or no relationship between two variables. While the alternative hypothesis or alternate hypothesis, there is a relationship between two variables. A null hypothesis, the researcher tries to disprove, while the alternate hypothesis, the researcher tries to prove. A null hypothesis, it is devoted by H0 or H null, H0 or H not, while alternate hypothesis is devoted by H1 or HA.
We have tabular value of Z at 0.01 and 0.05 level of significance. What is the use of this tabular value of Z? The use of this tabular value of Z is for us, for the researcher to use to compare against the Z computed, which will be talked about later, the Z computed. Ito yung ginagamit or basihan para malaman ng researcher kung i-accept ba ang alternative hypothesis and i-reject yung null hypothesis, so as vice versa. So, we have two types of tests under Z-test. We have one-tailed test and two-tailed tests. And one-tailed test, ito yung malalaman natin na one-tailed test ang problem kapag may sign na or symbol na less than and greater than. And it is two-tailed test kapag may symbol naman na not equal. So, under the 0.01 level of significance, ang one-tailed test, ang value niya is positive or negative 2.33. Tapos sa two-tailed test naman is positive or negative 2.575. Under the 0.05 level of significance, the value of one-tailed test is positive or negative 1.645, and for two-tailed test naman is positive or negative 1.96. So, paano natin malalaman to accept null hypothesis and reject alternative hypothesis and vice versa? Ganito. If the value of Z if the absolute value of Z computed is greater than the absolute value of Z tabular, we will be accepting the alternative hypothesis and reject the null hypothesis. But if the absolute value of a Z computed is less than the absolute value of Z tabular, null hypothesis is accepted and alternative hypothesis is rejected. Please be aware about the symbols and what we accept and reject between the two hypotheses. Next is, there are two ways where z-test can be applied. One is for one sample mean test, and number two is two sample mean tests. For example, number 1. Suppose a sample size of 100 units has a sample mean of 2.7 and a standard deviation of 1.5. Assuming normality of the data, then test the null hypothesis, which is population size is equals to 3 against the alternative hypothesis, which is population size is not equals to 3. Then use level of significance 0.01. Level of significance is indicated by letter A or the alpha. So, solution. Since our alternative hypothesis is population size is not equals to 3 and the sign is not equal, then this given example is two-tailed test. But when the alternative hypothesis is talking about less than and greater than, then the test is one-tailed test. So in testing the hypothesis, we have 6 steps. For number 1, state the null and alternative hypothesis, and the given example a while ago is nakastate yung null and alternative hypothesis. Our null hypothesis is population size is equals to 3, and for our null hypothesis, population size is not equals to 3. Step number 2 is state the level of significance. And again, nakastate yung level of significance natin sa example na binigay or binasa ko kanina, which is 0.01. So for the third step, find the value of z and the tabular value of z using the level of significance. So we have a table here, yung tabular value of z. Since this example is two-tailed test, sa two-tailed test tayo mag-focus under the 0.01 level of significance. That means, ang z-tabular natin is positive or negative 2.575. Okay? Next step is compute the value of z. So, in computing the value of z, we have the formula. Z computed is equals to the difference of sample mean and population size multiplied by the square root of sample size and divide by standard deviation. So, let's do substitution. Sample mean is equals to 2.7 and our population size is 3. Then our sample size is 100 and our standard deviation is 1.5. After substituting, perform the indicated operation. So, 2.7 minus 3 multiplied by the square root of 100 and divided by 1.5, we will come up with the answer of negative 2. That's why our z computed is negative 2. For our fifth step, making decision. The decision will be accept null hypothesis and reject alternative hypothesis since the absolute value of z computed is less than the absolute value of z tabular, or that is absolute value of negative 2 is less than the absolute value of 2.575. So, how come na Paano natin malalaman na mag-reject tayo ng null hypothesis and accept ang alternative hypothesis and vice versa? Okay, ganito. When the absolute value of z computed is greater than the absolute value of z tabular, we have to reject the null hypothesis and accept the alternative hypothesis. But when the absolute value of z computed is less than z tabular, or the absolute value of z tabular, we have to accept the null hypothesis and reject the alternative hypothesis. Please note the difference of accepting and rejecting the two hypotheses. For our last step is conclusion. Our conclusion would be, therefore, the mean of the population taken is equals to 3, or population size is equals to 3. Okay, since our example is two-tailed test, we also have to note that if the value of the level of significance is 0.05, then the absolute value of z computed is greater than z tabular. That's why we will be going to reject the null hypothesis and accept the alternative hypothesis. Since in the level of significance 0.05, the z tabular is equals to 1.96, which is obviously mas malaki ang absolute value ng negative 2 sa absolute value ng 1.96. Next is, let's proceed with example number 2. A supplier sells ropes. He claims that the ropes have a mean strength of 34 pounds and a variance of 64 pounds. A random sample of 32 ropes selected from a shipment yields a mean strength of 31 pounds. Are you going to reject the claim of the supplier at 0.05 level? So, our solution, or our null hypothesis, is population size is equals to 34, and our alternative hypothesis is population size is less than 34. Since our alternative hypothesis is talking about less than, then this test is one-tailed test. So for us to test the two hypotheses, let's proceed with our first step. For our first step, we have to identify or state our null and hypothesis. For our null hypothesis, we have population size is equals to 34, and our alternative hypothesis is population size is less than 34. Next is to find the level of significance. And based on the problem, we have 0.05 level of significance. Then for our next step is for us to find the value of z tabular under the level of 0.05. And the value would be z tabular is equals to negative 1.645. The next step in testing the hypothesis is by computing the value of z. To compute the value of z, we have the formula z computed is equals to the difference of sample mean and population size multiplied by the square root of sample size and divided by standard deviation. And for our next step, in solving the z, we have to do substitution. Our sample size is equals to 31. Our sample mean is equals to 31, and our population size is 34. Our sample size is 32 and our standard deviation is 8. How come na nakuha natin yung 8? Since our variance is given in the problem, standard deviation is equals to the variance divided by 2, or the square of variance. It means square root of 64 is 8. That's why our standard deviation is 8. So, next step is do the indicated operation. 31 minus 34 multiplied by square root of 32 and divided by 8 is equals to negative 2.12. For our next step is decision. This is the fifth step. Since our absolute value of z computed is greater than, the decision is reject null hypothesis and accept alternative hypothesis. Since at the level of significance 0.05, the absolute value of z computed is greater than the absolute value of z tabular, or that is, the absolute value of negative 2.12 is greater than the absolute value of negative 1.645. Kasi ang negative 2.12 is ang absolute value niya is 2.12. So in the negative 1.645, the absolute value would be 1.645, and obviously mas malaki yung 2.12. That's why we need to reject the null hypothesis and accept the alternative hypothesis. And for the last step is conclusion. Our conclusion would be, therefore, the supplier's claim is not true at 0.05, which is ang claim ng supplier kanina is 34 pounds. Ang kanyang ropes. Kaya mali or hindi tama yung kanyang claim. That's why, or hence, population size is less than 34.
What is z-test for two-sample mean test? The z-test for two-sample mean test is another parameter test used to compare the mean of two independent groups of sample drawn from a normal population. If there are more than 30 samples for every group. When do we use z-test for two-sample mean test? We use it when we compare the means of sample of independent groups taken from a normal population. Why do we use the z-test? We use the z-test to find out if there is a significant difference between two populations by only comparing the sample mean of the population. How do we use z-test for a two-sample mean test? We use the formula z is equals x sub 1 minus x sub 2 all over the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2, where s sub 1 the mean of sample 1 and x sub 2 the mean of sample 2. S sub 1 squared the variance of sample 1, S sub 2 squared the variance of sample 2. Note, in the given given is variance, there is no need for us to square it. However, if the given is standard deviation, then square it for it to become a variance. Then, n sub 1, size of sample 1, and n sub 2, size of sample 2.
Let's proceed with our last example. An admission test was administered to incoming freshmen in 2 colleges. 2 independent samples of 150 students each are randomly selected, and the mean scores of the given samples are sample mean sub 1 and sample mean sub 1 is equals to 88 and sample mean sub 2 is equals to 85. Assume that the variances of the test scores are 40 and 35 respectively. Is the difference between the mean scores significant or can be attributed to chance? Use 0.01 level of significance. So, as we can observe, or we can say that our null hypothesis would be population size sub 1 is equals to population size sub 2. And our alternative hypothesis would be population size sub 1 is not equals to population size sub 2. By looking with our alternative hypothesis, we can say that this example is two-tailed test since we have not equal sign. So to test our hypothesis, we have to do or we have to follow the 6 steps. So let's proceed. Step number 1 is to state the 2 hypotheses, which I had already stated a while ago. We have population sub 1, population size sub 1 is equals to population size sub 2 for our null hypothesis. And we also have population size sub 2 is not equals to population size sub 2 for our alternative hypothesis. And next, we have the level of significance, the 0.01. And for our step number 3, we have to find the value of Z tabular. And by finding that, we have to look again to the tabular value of Z, and we have to look at two-tailed since it is a two-tailed test, and we have to look in the 0.01 level of significance since it is the given level of significance. And the value of two-tailed test in the 0.01 level, we have the Z tabular is equals to positive or negative 2.575. Again, Z tabular is equals to positive or negative 2.575. Next is the computation. In computing the Z computed for 2 sample mean test, we have the formula. Z computed is equals to sample mean sub 1 minus sample mean sub 2 is equals to population size squared sub 1 divided by sample size sub 1 plus population size squared sub 2 divided by sample size sub 2. So, let's do substitution. We have 88 for our sample mean sub 1 minus 85 for our sample mean sub 2 all over square root of 40 since it is the value of population size sub 1 and we have to square it later. So, over 150 since it is our sample size. Then, plus 35 for our population size squared sub 2 over 150. So, let's perform the indicated operations. 88 minus 85 is equals to 3. And the square root of 40 over 150 plus 35 over 150 is 0.707. So 3 divided by 0.707 is equals to 4.24. And that is our Z computed. The next step is to make decision. So, since the computed value is greater than the tabular value, then we have to reject null hypothesis and accept the alternative hypothesis. So, to make for our last step, the conclusion, our conclusion would be, therefore, we can conclude that the difference between the mean scores is significant and can't be attributed to chance. We can conclude further as well that the examination scores of the students in the first college are better than the second. That ends our topic. I hope you understand our discussion. If you have clarification, just tell us right away. Again, our topic were about the Z-test, which in module 13. Thank you for listening and watching. God bless you all.